All right. We're in section 7.7 where we're going to be asked to solve any right triangles. So to review, we now have all three trig ratios that we have covered. So we talked about tangent, which was opposite over adjacent here. We talked about sine, which was opposite over hypotenuse, and we talked about cosine, which was adjacent over hypotenuse. So with those trig ratios, as long as we had an angle and one side length, we could solve any one of those, um, any problem that was given to us. Now, what we're going to look at now is we're going to look at inverse trig ratios. So let's say if we did not get any angle measures at all except for the right angle, but we were given at least two side measurements, we could figure out what an angle measure would be by using the inverse trig ratio. So to find an angle, we could possibly use inverse tangent, which is going to be opposite over adjacent. We could use inverse sine, which is opposite over hypotenuse, inverse cosine, which is adjacent over hypotenuse. Like it says here, we can figure out what angle measures we need to find and use the side lengths given to use the proper trig ratio. Excuse me. So here, in this example, we are given two side measurements. They're telling us that BC is 15 and AB is 20. So they want us to find the angle measures of angle A and angle C. So looking at angle A, we don't know what it is, but we do know that the opposite of angle A is 15. So opposite is 15 and the adjacent value to angle A is 20. So we know the opposite, we know the adjacent. The appropriate trig ratio is going to be the tangent. More specifically, we're going to look at inverse tangent. So the inverse tangent is going to equal 15, which is the opposite, divided by 20, which is the adjacent. So I go over here and I go, all right, so I have, so now in my calculator and most people's calculator, it's going to be the second button and you're going to hit the tangent, which is you're going to see a tan sign with a -1 as a like an exponent um, or a power sign. And then you just type in 15 over 20 and I get a value of 36.87. All right, 36.87 degrees. So angle A is about 36.87 degrees. Now, there's two different ways that we can find C. One, we can look at using a trig function and say, all right, we are given opposite over adjacent. We're going to use tangent again. More specifically, we're going to use inverse tangent. And the opposite of this is 20 over 15. So again, type in second tan, which gives us inverse tangent, and we got 15 divided by 20, and that gives us angle C, which is about 53.13 degrees. Now, way you can check this out is say, okay, 53.13 plus 36.87 plus 90, because it's a 90-degree angle, this all should result is 180 degrees or something really close to that. And in this case, it is exactly 180 degrees when you add up all three of those angle measures together. So you could actually just find one angle measure and then use the triangle sum theorem and say like 180 subtracted by 90. In this case, you'd subtract it by 36.87 and you'd get your 53.13 that way as well. Okay, so more than one way to do it. Uh, and so we'll go from there. So however way you want to solve it is up to you. So in this case, they're asking us to solve the right triangle. All right, so to solve the right triangle, they want us to round decimals to the nearest tenth in this case. So what happens here is when they're asking you to solve a right triangle, they're asking you to answer all unknowns that we have. So what don't we know? So unknown sides and angles. So if we look at angles, the only one we don't know is angle X. And we look at sides, the ones that we don't know are X, Y, and Y, Z. All right, so in order for us to solve the right triangle, we must find those unknowns. So let's look at angle X. First, angle X is relatively straightforward because all we have to do for this is we just take 180 subtracted by 90 and then subtract it by 42. So it's 180 subtracted by 90 subtracted by 42, and angle X is going to equal 42 degrees. Oh, I'm sorry, 48 degrees, my bad. 48 degrees. Sorry about that. All right, so I'm just going to write that in there. Now what we have to do is find the side measurements for X, Y, and Y, Z. So let's look at, so we'll just call this X and we'll call this Y for simplicity. So it's normal practice to use most of the information that is given to you. It's only when it's absolutely necessary to use something that you already solved for. So I'm going to be using the 42 degrees because it was given to us. I'm going to be using the 50 degrees because it was given to us to help us find X and Y. Okay, so 42 degrees is opposite of X. So I have opposite over hypotenuse. 50 is our hypotenuse. So opposite over hypotenuse is sine. So sine of 42 is going to equal X over 50. So to solve this, multiply 50 to both sides, and I got the sine of 42 times that by 50, and that means that xy is going to be equal to about 33.46. Okay. Now you can use the Pythagorean theorem if you would like, but I'm just going to keep going with the trig ratios for defined yz, which in this case we denoted as a variable y. So from 42 degrees, it's adjacent over hypotenuse, so it's going to be cosine of 42 degrees, so that equals y over 50. Same thing, multiply 50 to both sides. I get cosine of 42 degrees, multiply that by 50, and that means that yz is going to equal something close to about 37.16. So I found all the unknowns. I found my angle, x, which is 48 degrees. I found xy, which was 33.46, and I found yz, which was 37.16. Okay, so here we have triangle QRS, and again we have to figure out our unknowns. So for side measurements, we just don't have QS. And then for angles, we're missing two angles. We're missing angle Q and we're missing angle S. So You can start with whatever one you like. My plan is to start with the side measurement. And in this case, the side measurement here is C using the Pythagorean theorem, a squared plus b squared equals c squared. So 12 and 8 are my legs, so those are a and b. So I can say that 8 squared plus 12 squared will equal c squared. Uh, 8 squared is 64. 12 squared is 144. Add that to 64, we get 208. And so to find, we need to take the square root of 208. And that gives us a approximate value of 14.42. Okay. I guess they wanted June. I think the direction said the 10th. Oh, crap. So let's change it. 14.4. So then these other ones, this one would be more like 37.2 and 33.5. Okay. Sorry about that. I didn't read the directions. All right. So now um, we have all the side measurements, so that's done. So this is QS is 14.4. Now we have to find angles Q and angles S. So I'm going to look at angle Q first. And again, just like in the triangle above, let's use the information as given to us. So we're going to use 8 and we're going to use 12. So from Q, the opposite is 8 and the adjacent is 12. So opposite over adjacent is tangent, but we need to find the angle measure. So we're going to look at the inverse tangent, and that's going to be 8 over 12. So go inverse tangent of 8 over 12. And that's going to equal roughly 33.7 degrees. So 33.7 degrees. And then I go angle S over here. S in this case, opposite over adjacent, we're going to use inverse tangent. And that's going to equal 12 over 8. So inverse tangent of 12 over 8. And that equals, what, 56.3 degrees. And again, 56.3 plus 33.7 plus 90 comes out to 180. So that makes sense. So now we have all of our unknowns. All right, so last thing here, it says they want us to approximate angle measures to the nearest tenth of degree. So if you have a value sine A, so that means we're trying to find angle A if you had a triangle, and it had A as one of the vertices. You're trying to find angle A. Well, they're telling you that sine of A equals 0.87. So to find the angle, you're just simply going to take the inverse sine of 0.87, and that gets you a value of 60.5 degrees. Go and look at B, inverse cosine of 0.15. That gets you a angle measure of about 81.4 degrees. And then finally tangent, you got to take inverse tangent of 0.75, and that gets you something about 36.9 degrees. And that is being able to solve right triangles. Hope this helps. Till next time.